Hello friends, the topic of discussion today is biostratigraphy and its application. We'll try to understand what is biostratigraphy correlation, and what are the applications. Applications like as we can see, the biostratigraphic applications involved in hydrocarbon exploration, then to recognize the trap rock from like in subsurface mapping, to reconstruct the paleoclimate and paleoenvironmental condition, then to refine the geological time scale. So we'll deal here one by one. So first, what is biostratigraphy? Biostratigraphy is simply is the branch of stratigraphy that deals with the characterization and correlation of the rock units on the basis of their fossil contents. So this is a very simple, like as we classify the rock on their basis of their minerals, their color, texture. So here we classify the rocks on the basis of their fossil content, rock strata. This is not a piece of rock. We will classify the rock strata on the basis of their fossil content. So the concept of biostratigraphy is based on the principle that organisms have undergone successive changes throughout the geological time scale. So this principle is known as what? This is a very well-known principle. The principle is known as the principle of funnel succession. So the principle of funnel succession tells that in different rock types, suppose in ancient rock there will be older forms which are more evolved, whereas in like younger strata we can find the more advanced form which have many specialized organs and all. So then on the basis of the content fossil, any stratigraphic units can be differentiated from the stratigraphically younger and older units. As I told, the older strata consist of ancient forms, and the younger strata consist of advanced forms. Then purpose of biostratigraphy, what are the purpose, like why there are different branches, why we used to study biostratigraphy. So the purpose are differentiation of strata. What is differentiation of strata? So the differentiation of strata means it is the means in a formation there is a different rock stratas. How we will differentiate, how we will name them? Suppose lithostratigraphically it is named, but in biostatic, suppose somewhere there is a huge thick of sandstone, so we cannot differentiate them lithologically. So how can we differentiate them? So here it comes the biostratigraphy. So in biostratigraphy, in biostratigraphy, the fossils on the basis of fossil contents, we can characterize, we can differentiate the rock strata from one unit to different another unit. Then the correlation of strata. The suppose here one strata, one lithosection is there, and another far distance there another lithosection is there. So we can correlate them on the basis of fossil content. And then interpretation of earth history, the evolutionary history and the evolutionary biology. By studying the fossil, we can say, suppose in ancient there is suppose in ammonite, as we know, there is a different type of different type of that sutures. We can see the orthocera as like very simple, that is depend the ancient forms, and the other like goniatite and all, they will depend the more advanced forms. Like that we can study the evolutionary biology. So during study the biostratigraphy, first we should know what is biozones and zone fossil or index fossil. So opal introduced the concept of zone. What is zone? Zone is a fundamental unit of biostratigraphy. As you can see, there is a fundamental unit of lithostratigraphy, that is formation and all. So here the fundamental unit is zone. So he conceived the idea of small scale unit defined by the stratigraphic ranges of fossil species irrespective of lithology of the fossil bearing bed. So here lithology, there is no there is nothing to deal with the lithology of the studied section. So the means there is a section, suppose it consists of several stratas. So the lithologically they may be different, but if they are consisting of same fossils, so we can put it into a same stratigraphic biozone. So here nothing to deal with the lithology of the strata. So each opal zone was named after a particular distinctive species called an index fossil. So what is index fossil? The definition of index fossil is different. Like the fossil which consists of the fossil which represent a narrower geological range, that is temporal, that is in time scale. They have very narrower range, like but they have very widespread evolution. Like they have their abundance is very high, and they spread throughout, like covering a very large geographic area. So this is a index fossil. But in suppose in stratigraphy there is a biozone that is named after a index fossil. Suppose I can say means I was during my research I was dealing with fossil ostracode. So we have also made several ostracode biozones. So one biozone I recognize as uh, fastigator saither habo saither assembly zone. So here fastigator saither habo saither we can see we can consider it as index fossil. So another index fossil we have introduced another zone, like Manjugella perforata cochensis, Galliocytheridia remota concurrent range zone. So here another concurrent range zone we have established. Here Manjugella perforata cochensis and Galliocytheridia remota. These are two species. These are index species. Here these are index species. So, but one of the species of the assemblage that characterize the zone. This is the simple biostratigraphic biozone definition of biozone. Then biozone is named after index fossil selected for their distinctiveness or abundance. So how will there will be many fossils. So how will take one? So based on their distinctive occurrence, like it should occur throughout the section. It should occur concurrently, like two species overlapping. They should occur overlapping, like one sorry, one is occurring like from, suppose this is a section, there are two fossil. Here one fossil occurring from here to here, another fossil occurring from here to here, another fossil occurring from here to here. So they should be different, like these two are no these two can be established as one concurrent biozone. So an ideal index fossil should have narrower temporal range, that is have undergone rapid evolutionary change but have had wide geographical distribution. What I have already told, they have narrow geological range but wide geographic distribution. So this is the well-known geological time scale, and how the what are the different fossils, representative fossils that characterize the biozone, biostratigraphy of the specific age or period. So for Cambrian period, we can see trilobites are very important. As you can see here, it is it can be shown in dark gray. So here for trilobite, for Cambrian, trilobites are very important for biostratigraphy. Then brachiopods are very important in Silurian to Permian. Then similarly gastropods are very important in Cenozoic. Then graptolites are important from Ordovician to Silurian. Bivalves are very important in Cenozoic, and corals are also useful in Devonian to Carboniferous. Then echinoderms are very narrower range in Cretaceous. They can also used in stratigraphy, biostratigraphy. Like ammonoids are very wide range from Devonian to Cretaceous. They are widely used in stratigraphy. Whole the Jurassic of Kachchh Basin has fastly established on the basis, the biostratigraphy has been established on the basis of ammonites. Then after all other brachiopods came, there is biostratigraphy of brachiopods, there is biostratigraphy of bivalves. Also, we have established several ostracod biozones in Kachchh Basin. Then foraminiferae are all very important. Then nanofossils, several fossils came. But ammonite, the biostratigraphy of ammonites are very important in Jurassic of Kachchh Basin. Then foraminiferae are very important from Jurassic to recent. Then conodonts are useful in from Devonian to Triassic. Then calcareous nanofossils are also important in Jurassic and Cretaceous. So then we will study the types of biozone. What are the different types of biozone? These are very important topics. So the first biozone is range zone. There are two range zones. One is taxon range biozone, then another is concurrent range biozone. What is taxon range biozone? A body of rock representing the known stratigraphy and geographic range of occurrence of a single taxon, defined on the basis of FAD and LAD of the single taxa. FAD means first appearance datum and LAD means last appearance datum. So here what it says, suppose here this is a rock strata, this is this is a rock strata, or there are multiple rock strata. So there is a single fossil that first appearance here, FAD is here, then LAD is here, LAD is here. So based on this fossil we can establish a taxon range biozone. So uh, how we can say it, like suppose this fossil species name is A. So A taxon range biozone. So we can name it like this. For example, there will be different there will be several example for this taxon range biozone. This is very important. So there will be several examples. I will say that later. Then concurrent range biozone. Range biozone, as I have already told, a body of rock that includes the concurrent or coincident or overlapping of part of the ranges of the two specified strata. Here what happens? Suppose this is several rock stratas. One fossil starting from here and ending from here. Then another fossil starting from here, then ending from here. So from this part of the strata, this from here to from here, this part where these two fossils are overlap, they have overlapping characteristics. Suppose this is fossil A, this is fossil B. So this part is this part of this data, they have overlapping characteristics. So what we can say, this here we can establish a concurrent range zone. So it will be A B concurrent range zone. I have given one example, that is we have established one concurrent biozone. This is very important for my research, that is Manjungela perforata cochensis and Fastigato Cythera and Gallioscytheridia remota concurrent range zone. That is a ostracode biozone. That is there is overlapping of Manjuvilla perforata cachensis and Gallioscytheridia remota in my study area. Then interval biozone. Interval, the body of strata between two specific biostratigraphic surfaces. These surfaces are commonly based on the lowest and highest occurrence of the strata, and there will be no overlapping. Here, there will be no overlapping. So we can best explain it in figure. So this, as I have already told, this is a range zone, this is a concurrent range zone where this part is overlapping. So this part can be this, suppose this is fossil A, this is fossil B, this is the range of fossil A, this is the range of fossil B. So we can say it as A B concurrent biozone. But in interval range zone there is no overlapping. There is one fossil is there. There is one fossil. This is the last appearance. Last appearance means after that this fossil will be. We cannot find this fossil from this data. So this is the first appearance. This is the last appearance. This is another fossil. This is, suppose this is A. This is B. So the appearance of fossil A is ending here, but the appearance of fossil B is starting here. So this zone where the interval zone, there will be interval. As we can know, the interval in movie, there will be interval when one part is already over and another part is left, and this interval some they will run some ads and all like that. Here this life cycle of species A is ending here, and there is life cycle of species B is starting here. So this interval time is known as interval biozone. So how we can say A and B interval biozone. Similarly, partial range zone is also similar to interval biozone. This is, they have no such importance, and partial range zone also a type of interval biozone. Then we will go to lineage biozone. What is lineage biozone? This data containing species representing a specific segment of the evolutionary lineage. So here another image is there. So we can see here 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 this is the lineage biozone. Here species A is there. Species A continues after with some evolution, and then species B appear, then species C appear. So this part, what this part represents, it represents the evolution, how the species A evolved from A to B, from B to C. So this suppose we are finding such kind of scenario in a rock section, we can name it as what, lineage biozone. So suppose one foraminifera is there, suppose there is coiling, suppose there is simple round simple planispiral coiling is there, then it goes to trochospiral, same species, then it goes to another kind of like multispiral. So this suppose we can find in a rock section, we can find this kind of evolutionary scenario. So we can name it as lineage biozone. Then another two biozones are there. Assemblage biozone. Assemblage biozones are the unique association of three or more taxa in a single group. What it says here, the here suppose here there is fossil A. This is range of fossil A. Here it is appearing first, this is last appearing. This is fossil B, this is C, this is D, this is E. There are five species or taxa are there in this data. So what we can see, but this is more than 3. So if there is 3 or more taxa, of same group. Same group means we cannot say like one ostracod is occurring, one foraminifera occurring, one nanofossil is occurring, so we can consider it as a assemblage zone. No, this is not the case. What we can say, if three species of only ostracod, or if three species of only foraminifera is occurring, suppose three or more species of ammonites are occurring, in that case only we can say it as assemblage zone. So this is the assemblage zone. This is also very simple. Like here we can name, we can here A, B, C, D, E are there, so we can name A, B, C, D, E assemblage zone, biozone. So then abundance or acme zone, the strata in which abundance of particular taxon or specified group of taxa is significantly greater than the adjacent part. So this is also very simple. So what is there? Suppose there is a fossil, fossil species or taxa, that is fossil A, and this is the strata we are studying, and this is here another strata is there. So where what in this case? So their abundance means number of fossils, number of specimens means number of fossils, how many fossils we are getting. So here suppose in lower part we are getting 10 fossil. Here in the lower part we are getting 20 fossil. Suppose here we are getting 50 fossil. But here in the middle of the strata we are getting thousand of fossil, thousand fossil. Here also we are getting thousand fossil, thousand or 700 fossil. Here we are getting again 40, here again 10, like that we are getting. So what happened, this the suppose there what happened, suppose this species started from here, this species ended here. So there will be a optimal, this data represents a optimal environmental condition where it gets nutrients, oxygen, very good amount of oxygen supply, then what the sunlight. So they grow very significantly higher in a number than the previous or the lower and upper strata. So this is a acme zone. Suppose this is a fossil A, so we can name it as a acme biozone. Suppose like if we are getting foraminifera like this, so this foraminifera acme biozone. So I have already discussed this taxon range biozone, concurrent range biozone, interval range biozone, then partial range biozone, phylozone or lineage biozone, assemblage zone, then another acme zone was there. Then biostratigraphic correlation. This is very simple. Like this rock stratas in distance, they are separated by a great distance, but they have same fossil content. So same fossil content will be available on same geologic age. Like suppose in Cretaceous Trichinopoly we are getting some one species, and same there are chances we can get same species in Kachchh also. In Cretaceous there is also Cretaceous deposits in Kachchh also, so we can get similar fossil. There are chances, means I am not saying it will be occur, but there is a chances. So in that case we can correlate, like we can correlate means they may be as there are correlation, so they are deposited in a single time, means during when this rock are deposited, at that times this same rock is deposited. So biostratigraphic units are observable. Objective biostratigraphic units identified on the basis of their fossil content. Objective of the biostratigraphy, as such, they can be traced and matched from one locality to another, just as lithostratigraphic units are traced. Means how we correlate lithostratigraphically. Suppose here one rock is there, here one rock is there. here one sandstone is there where glauconites are present. Here another sandstone is there similar character, similar texture, structure and color. Here also glyconites are present, so we can correlate this. Means here the mineral glyconite is the bridging mineral, bridging like bridging mineral in the two strata. Here similarly here fossil used to as used as the bridging like bridging material. So here similar species is there, here similar species there, so we can correlate these rock stratas. Here similar species is there, here similar species is there, we can correlate this strata. This is very simple. Then there are some examples of different there are some examples of different geologic age and their characteristic like biostratigraphic zones. For example, for Ordovician, Cambrian Ordovician of Spiti, the trilobites are mostly used. What are the zone? Ridleychia zone for Lower Cambrian, Paradoxite zone for Middle Cambrian, Agnostos zone for Ordovician. Then there for Jurassic of Kachchh, like middle to upper Jurassic, Calovian to Oxfordian, there are several ammonite zones. What are these zones? For lower Calovian, macrocephalite zone. For middle Calovian, Renicia or Ansep zone. For Athleta, for upper Calovian, that is Athleta zone. For Oxfordian, Perispint zone, and then for upper Oxfordian, Peltoceratoid zone. These are very important to remember for different exams. Like so for Cretaceous of Cauvery Basin and Trichinopoly, also ammonoids are there. For Albion and Cenomanian, Mortoneceras and Acanthoceras zone are there. And for Turonian and Santonian, Texanite and Placenticera zone are there. Then for Siwalik of Miocene, Siwalik rock representing Miocene to Pleistocene rock, fossil used here are vertebrates and palinoflora. So what are the vertebrate fossil? Hipparian biozone for middle to late Miocene, Elephas at Stegodon for plio to Pleistocene rock. Then there are also some drawbacks in biostratigraphy. Then there are some questions we have to ask before establishing a biostratigraphic zone. So are you looking at appearance or unconformity? Meaning, are you looking at last appearance or unconformity? Like suppose we are getting one species. Suppose we are getting one species from here, and it is continue. Suddenly there is no appearance. This is actually truly this is the end of this species, or this is a period of non deposition or erosion representing a unconformity. So we have to very cautious about this scenario. Like we are getting a conglomerate bed, and we are getting a period of non deposition or erosion, so we cannot say this is the last appearance. So we have to very cautious about on this aspect. Then phases dependence. Biostratigraphic are phases dependent. Like suppose one cell, we are getting cell phases. So microfossil will be there. Then suddenly the phases will be changed. Like from cell to sandstone. So in sandstone we cannot get what the microfossil. So how we can say that the fossil will not be there? The fossil will be there, but as where the phase is changing, so there will not availability of the fossil. Then regional speciation and extinction. Regionally, like some locally they got extincted. So in that case also, we have to very cautious about that. Then shifting of climate zones or biogeographic province. Then the climate, suppose or one temporal climate is there where one fossil is growing very fast, but there is shifting of the climate. So in that case, climate is the driving phenomenon, driving the biostratigraphy. So this is not the nature. This is the not the naturally appearance or disappearance of the fossil. This is driven by the climate. Then other challenges are the preservation problem. Poorly preserved organisms and less abundant organisms are unlikely to be found. So suppose one fossil is there, these have very hard calcareous rock, they have preserved very greatly. But another fossil is there, they have very soft, like their hard part is consist of very soft material, so they got dissolved during the deposition or sedimentation. So in that case, the fossil is there, so but we are not finding these fossils, or some broken fragments are we are getting, or some dissolved fragments are we are getting. So in that case, this is also a problem, like uh, we can also establish fossil on this another establish a biostratigraphic zone on the basis of another fossil, but as we are not getting because of the poor preservation, so this is also another problem. This signal cliff effect. Poorly the preserved fossil, less abundant species appear to go extinct, what I have told. Like poorly preserved fossil, suppose in suppose one foraminifera is there, they have very fragile cell. So in upper part we are getting, but in where we are going to lower part, we are not getting because of the they cannot preserve very for a long time. So we generally consider as they have gone extinct, but that is not the scenario. What is the scenario? That is the true scenario is the fossil is continues, but due to the preservation phenomena, we are not getting this fossil. So this is another challenge. Then zombie species. What are zombie species? Zombie species are some species extincted very much before, but from the older rock strata, they have eroded and they have deposited in the younger strata. We are finding in the younger strata. So in younger strata also we are getting the ancient forms. So this we can say as zombie species. So zombie species also a very significant problem in biostratigraphy. The ancient form who have gone extincted much before. Suppose conodons. Conodons are found up to the Triassic. Up to Triassic, after Triassic, we are not getting conodon. But in suppose one fellow is working on Cretaceous, but he's getting conodons. So what he will present conodons are he is getting from Cretaceous rock, and this is the conodon biostratigraphic zone. But this will be the wrong interpretation, because they have got extincted much before in Triassic. So this is another problem in biostratigraphy. So